Whenever we take a measurement of something, there's always inherent limitations of that measurement. There's always an uncertainty with that measurement. So, for instance, if you have a penny and you're trying to measure the width of that penny, or the thickness of it, you could use a measuring tape. That's one way to measure it. But there's, you can only get so accurate there. And so you might pull out calipers and get a bit more accurate, and you can get a couple more decimal places of accuracy. Or you could take it to a lab and they could look at it with an electron microscope and get it down to, really, really, really accurate. Inherently, though, even in that situation, there's still going to be some limitations. So what we do when we to express the uncertainty when we're dealing with these answers is we round to a certain number of significant digits. So what I mean by significant digits here, first off, we need to define significant digits. First off, anything that's not a 0 is considered significant. These rules here that you see, these are only rules regarding zeros, whether or not trying to figure out if a 0 is significant or not. So I guess rule 1, digits other than zeros are always significant. There you go. Rule 2 says we get 0 is significant when it appears between two significant digits. So like in the example A here, you can see this 0 is between the 3 and the 4, so it would be considered significant. If it appears at the end of a decimal number, it's considered significant. So down in example 3 here, this 0 is significant because it's to the right of the decimal place. It's at the end of it's at the end. Versus these ones right here, in contrast, these would not be considered significant. Although I guess that's rule 3, isn't it? Or it's considered significant if there's an overbar. So going down to part E here, the overbar, this line over the top of this 0, we use that to indicate that this should be a significant digit, even though it's, normally if it didn't have that overbar there, it would not be a significant digit. We only do the overbars when we're to the left of, or the overbars only mean significant digits when we're to the left of the decimal place. Normally, if we do something like 3.3 with an overbar there, that means 3.3 repeating. This is something different, though. 100 like this would mean that this 0 is significant. We would have two significant digits in this particular number, this 1 and the 0 with the overbar. Alright, so rule 3 goes out of the way to specify when zeros are not significant, and basically it's every other time we see the zeros. So if it's at the right end of a whole number, so like these ones right here, those would not be considered significant. The ones on part B, those 3 would not be considered significant. And then if it's at the left of a number, so on this one right here, that actually, I guess not just that 0, all 3 of those zeros would be considered not significant. You can see these zeros here and these ones here are mostly just so that we can make sure that the decimal place is in the correct place. And the only reason we have them there is to make sure the decimal place is in the correct place. Other than that, we're going to say these are significant. These rules, we say they're significant. So if we want to determine the number of significant digits of these following measurement numbers, this one has 3 significant digits. The 0 being between the 3 and the 4 means it's significant, so that one has 3 significant digits. This one only has 2, the 3 and the 8. This one has 1, 2, 3, 4, 5 significant digits. That ending 0, since it occurs after the decimal place, is significant. Basically, there would be no other reason to have the 0 there other than to indicate significance. That's kind of what we use as our guideline here. 0.005 volts only has 1 significant digit. This 18,400 with the overbar, the bar over this first 0, we have 1, 2, 3, 4 significant digits here. And 200.0, this one might appear that it only has 1 significant digit at first, but I guess I should say, digits other than 0. Okay, yeah. Rule 2A here says if it appears between 2 significant digits. It's not just between 2 non-zero numbers. So for instance, this one, that 2 is definitely significant. This 0 is significant, which makes these zeros also significant because they're between 2 significant digits. So this one would actually have 4 significant digits. So the whole point of these significant digits is to show what sort of errors can be associated with these numbers. So this number means that 3.04 means that it's accurate to the nearest hundredth of a pound. This 38,000, since those are not significant, this means it's accurate to the nearest 1,000 miles. This 15.730 seconds means it's accurate to the nearest thousandth of a second, because this is the thousandth place. This one here, yes, I suppose it does mean it's accurate to the nearest thousandth place, thousandth of a volt, but you know, we don't have very many other digits of accuracy. So I'll talk more about that in a second.